Hi, everyone. We're going to get started with the webinar. My name is Caitlin Onthank. I'm the marketing statistician here at Salford Systems. I want to thank you all for joining us here today for this webinar. I hope you will be able to take away how you can enter a KDD Cup or a Kaggle competition and realize that you don't need to be an expert to do one of these data mining competitions. So I want to mention that after this webinar, you will be getting a follow-up email, which will have the recording of the webinar. We're also going to send you the data sets that I used today, along with a step-by-step tutorial that you'll be able to replicate yourself when you download our software, a trial version. We also have another webinar coming up on February 10th. It's called 3 Ways to Improve Your Regression. And we also want to make sure that you provide up-to-date email addresses with us so that you can receive this information. And if you have not, you can go ahead and email us at support@salford-systems.com. Okay, so the focus of this webinar is going to be the KDD Cup from 2009. And the main theme of this competition was customer relationship prediction. And I have a screenshot here of the site, but I'm actually going to take you to the site so we can look at it together. So KDD is a data mining, data science, and analytics community. They put on a conference every year, and they also hold this KDD Cup, which is a data mining competition where they give you a challenge, a set of rules, some data, and anyone that wants to enter can compete to get the best results. So as you can see, they lay out the challenge here. They have the tasks, the rules, the data, and then they'll put up the results after the competition is over. So this challenge for 2009 was customer relationship prediction. And a telecom company in France called Orange wanted to predict a couple of key things about their customers. So they handed over this huge database to KDD, and they had 3 target variables: appetency, churn, and upselling. And they wanted to know how their customers were going to behave so that in the future they could tailor their marketing efforts in a better way. And so, come back to the PowerPoint. So there were 3 classification tasks. Like I mentioned, appetency, which is the probability that a customer will buy a product or a service. Churn is the probability that a customer will switch providers. Upselling is the probability a customer will buy an offered upgrade. And there were 15,000 predictors in this data set. Now, the company wanted to keep things kind of private, so they did disguise these variables. But typically, marketing variables would be demographic, geographic, and behavioral data, such as website visits. And the way that the competition was judged was each model was built, and you would get an ROC curve, like the one pictured here, for each model, and you would average that to get the score. And the judges would use a separate test data set to see how your model performed on unseen data, which is how it would work in the real world when you're trying to predict how a customer is going to behave. So this wouldn't be a data mining competition without a few challenges. KDD didn't want to make it easy for anybody. But like I said, this is a pretty large database. It was only 50,000 customers, which isn't a lot, but the 15,000 predictors was what made this a hard task. These predictors were numerical and categorical. There were a lot of missing values, and the categorical variables also had a high number of levels. Additionally, the unbalanced class distributions made this a little tricky because many more customers were not buying products or not buying upgrades. So there were a lot less ones in the data set than the negative ones of the binary variables. So we'll get to the good stuff on how to participate in these kind of competitions. We approach this through a TreeNet Gradient Boosting, and TreeNet is our software that does stochastic gradient boosting, which is sequential error correcting cart trees. And there's a picture here below that shows the beginning of this process. So each cart tree is built, and after the first tree, you are trying to predict the residuals from the previous tree. And we showed 3 trees here, but typically we build a minimum of about 200 trees. And we found the software to be very fast and accurate, and it worked really well in this situation. And we also have the problem of variable selection. Because there were 15,000 predictors, we really wanted to shave that down to a smaller amount so we could deal with it in a better way. So every decimal place counts here, and this is one of the big differences in these data mining competitions versus everyday modeling. In everyday modeling, you'll be happy with a decent model of about, say, 90.90 ROC value, but here, entries in the competition were only separated by 0.0001 in some cases. So every single decimal place counts here. And we wanted to show you how you can extract every possible relationship to get your results up to the top of the pack. So before we look at the results, I'm going to go into the software now so I can show you how we approach this competition. So what you see here is our Salford Predictive Modeler. This is version 8.0. What you'll be downloading is 7.0, but this faster version that I'll be working with now will be out in the near future. So first, I'm going to open up our data set. So this folder that I have here has 4 data sets in it, and these were the 4 that were provided by KDD. There are 2 large data sets for training and for testing, and 2 small data sets for training and testing. The small data sets were provided because they hold a smaller number of predictors for people who couldn't handle the 15,000 at first, and we'll be taking a look at that later. As for the 2 large data sets, there's a training data set, which is what you build your model on, and then the testing data set is what the judges would take that you score your model on, and they can see the target variables. So that data set does not have any target variables in it for us to work with. So for now, we're just going to work with the large training data set. It does take a few seconds to open because of its large size. And like I said here, using 15,000 predictors is a lot. And in addition, we don't know what those 15,000 variables are. As you can see here in this window that pops up, we have our variables listed on the left: appetency, churn, upselling, and 15,000 predictors. We can take a look at the data in a spreadsheet. You can also see there's a lot of zeros here, and this was another big problem with the data. If you scroll to the end, you can see that our target variables take on values of -1 and 1, and you can also see how the categorical variables to the left were disguised as these categories. So you really couldn't draw any insight from the data on your own by just looking at the names of the variables. So what we're going to do next is go ahead and set up a model. So like I said, we're going to use TreeNet Gradient Boosting. And I can select that here from the Analysis Engine menu. We have other engines that can be used in combination with TreeNet. And they also, other learning capabilities of our machines do different things, and you're welcome to try those out in our trial download as well. So we're also going to choose target type classification because our target variables take on values of -1 or 1. I'm going to illustrate with the appetency target first. So I select that in the target column, and I select the remaining 15,000 predictors in the predictor column. And you can double check that over here to the right. Now, as I mentioned before, the competition provides you a test data set to score your model on, and the judges will test that with their target variables to see how well your model did. And unfortunately, we don't have access to those target variables, so we have to make do with the training set that we have to see how our model is performing. So I'm going to go to the Testing tab in Model Setup. And we're going to choose a test partition of selecting 20% of the cases at random. This means we'll build our model on 80% of the data and test on the remaining 20%. Additionally, you can select here that the test sample is contained in a separate file, and we would do that if we had the target variables on that test data set. We also have cross-validation, which on such a big data set such as this one, it would take quite a while to run. So we're going to stick to the 80-20 partition. In this TreeNet tab here, we have a couple more options where you can fine-tune your model. Since we're looking at the area under the ROC curve for evaluation purposes, we're going to select that to select the optimal tree in our sequence with ROC area. You can see to the right that we're going to be building 200 trees to start. And I'm also going to impose some overfitting protection on this model. So what the learn rate means is the pace at which the TreeNet sequence that I showed you in the PowerPoint before is correcting itself. So if the residuals are correcting too fast, you may run into an overfitting problem. And if it's going too slow, you may have to build up to 5,000 trees or so just to get your model to an optimal point. So I'm just going to put 0.1 here, and all of these can be played around with, and you can change them as you go to get your model where you need it to be. One last tab I'm going to look at here is the penalty tab. As I said before, there were a lot of missing values in the data set, and there were also a lot of categorical variables that had a high number of levels. So we want to penalize those variables so they aren't playing a big part in the model. So I'm just going to set 1 for each of those. Make sure our model is set up correct with our correct target and predictors. And so this is normally where I would hit Start in the bottom corner here. Unfortunately, since this model is huge with the number of predictors, it will take 20 to 30 minutes for this model to run on your computer. So instead of sitting here and waiting, which would be rather boring on your end, I'm just going to hit Continue here, and I'm going to bring up the results that would come up from that run. So this is what I got from running that exact model there. It took about 20 to 30 minutes to complete. As you can see, we get a sequence here of trees. We built 200 trees, and it's graphed against the ROC value for each tree. And once we got to 55 trees here, we got our optimal ROC value, which you can see up in this table was 0.89926. Now this is a decent ROC value, and on a typical modeling exercise, I would probably say that I'm satisfied with this. But like I said before, we want to get as many decimal points closer to a winning result. So now we're going to do some variable selection techniques to try and whittle down that 15,000 predictor list. So what I can do here is click Summary. What this does is brings up a summary for that optimal model. It tells you a lot of different error measures. You can see our ROC on the test sample was 0.89926. But what I want to look at here is this variable importance tab. You can see down here that out of the 15,000 variables in the original data set, we are using 185 for this model. And that's a huge difference. We've already really narrowed that down, but I want to keep going a little bit further. What we're going to do here is we're going to see if we can take off any of the variables from the top of this list and from the bottom of this list to see if we can't improve the model performance a little bit more. So what I'm going to do is say Select All, and this will highlight all 185 variables in this list. I'm going to hit New Keep List here. And what this does is it brings up a notepad window with the command file for keeping those 185 variables in your next model. When I submit this window, it tells model setup to only use those 185 predictors, which you can double check in this box over here. So now we have some cool features in the software called automates or batteries. And what they do is they run a bunch of models at the same time that you can use to compare against each other. And one example is our learn rate battery. Like I said before, if you're not sure what your learn rate is, you can play around with it, or you can run this automation where you can choose different values of the learn rate and compare them directly against each other to see which might give you the best model. But for variable selection, we're going to use a battery called shaving. When I add this battery, it gives me some options. We can shave from the top, from the bottom, or we can do an arrow shave. And what this means is when I shave from the top, I'll be taking a certain number of variables off the top of that variable importance predictor list. And we can see if that makes any difference in our model performance. So what I'm going to say here is I'm going to say do 20 steps of shaving one predictor off the top of that list at a time, and then reevaluating the ROC. So I hit OK, and here I would hit Start, but again, I'm just going to hit Continue and show you what the results are. So we don't have a lot of waiting time. So this is the results window that will pop up after you have completed your shaving. And I can sort it by the ROC value. And as you can see in this graph, the ROC starts to deteriorate after you've shaved too many variables off the top. But we do get a better model performance when we shave the top variable off. What we do next is we can see that this is our best model here, highlighted in green, and we can double-click this model to open it up. So now we have a new model. This model now has 167 important predictors. So we want to take those predictors again, as we did before, from our variable importance tab. I'm going to select them all, create a new keep list, and submit this keep list to the model setup. Again, you can double check that you have the correct number of predictors here, 167. And now I want to do another type of shaving, this time from the bottom of the predictor list. And this might yield some better results. You might see more variables falling off of the bottom because sometimes the variables all the way at the bottom of the list have very little importance, and they're easy to get rid of. So in this case, since we still have 167 variables, I did 100 steps of shaving variables off of the bottom of the list. Again, I'll click Continue here and jump straight into the results. When we sort by ROC, you can see it jumped around quite a bit as we shaved predictors off of the bottom of the list. And by the fourth iteration of the process, we got our best ROC value of 0.90481. Now you can keep going with this process. You can do the error type of shaving, which I will explain in a little bit. And you can run a bunch of different automations to really boost your performance by a few decimal points. That would really help. For now, this is a very good ROC value, and I repeated these same two steps on the remaining target variables. So I did the same thing, except that for churn and for upselling in this model setup window. Same exact steps. So for the churn model, this was our final results window. So this is after running a full model, shaving from the top, and then shaving from the bottom. We have an ROC highlighted in green of 0.73455. Now this is significantly lower than the appetency model, but this is still the best churn score that we were able to get. I also ran the same steps for upselling. Again, when we sort by ROC, we can see that our max value is 0.90589. So with these three easy steps for building these three models, I can show you how these results scored. So this is a quick summary of the top 5 entries in competition for the fast track. The way KDD did this competition was they had a fast track over 5 days, and then they had a slow track over 2 months. So this was the fast track. And with the scores that I just showed you, we were getting an average ROC of 0.8484, which would have scored second in the competition. Now, this is pretty good considering the modeling time would take maybe about 4 to 5 hours with all of the waiting compared to the 5 days that contestants were given in this track. I do want to mention again how we can't really compare these directly just because we don't have the true target values that the judges had access to. But we are pretty confident that our software would do well, and we do know that some of the contestants used gradient boosting, and at least one of the contestants did use our software for this competition. Results can obviously vary based on a number of different things. If you decide to use a different optimal selection criterion or a different random number seed. But overall, this was a stable ROC score that we received from the models. So we want to look at some actual software runs now, instead of just pulling up results. And like I said, we were given a small data set to work with in the competition. And this is for people that might not have the capacity to handle the larger data set, and for people that just wanted to play around with the data and not commit to such a large set of predictors. So what I will do is open up the smaller data set. This is the small training data set here. As you can see, there are only 230 predictors in this list. And this data set was made available to the contestants of the competition. But they obviously wouldn't want to give away what their best variables were before the competition was over. So we can't promise that these are the best 230 predictors because that wouldn't make sense to release. So the performances on these models won't be as good as using all 15,000 predictors. We're going to go through the exact same steps I just showed you on the smaller data set, and we're actually going to run the model so you can see it in real time. We're going to select appetency as our target and 230 predictors. Make sure we're using TreeNet down here in our analysis engine drop-down menu and classification as the target type. When we go to testing, again, we want to make sure we have our 20% testing partition. And I will show you at the end of this model run how we can use our model to score on the test data set that was provided. I'll come in here again, make sure we're clicking ROC area for our optimal selection criterion. We're building 200 trees, and our learn rate will be 0.1 again. We want to make sure our penalties are still in place. And we're going to run this model. Now, like I said, TreeNet runs pretty quickly given the algorithm that's lying behind the software. I'm illustrating appetency as the target variable simply because that is the first one in the list, but the same process goes for churn and upselling. You will get the same runtime, and you will set it up the same exact way. You will obviously have a different predictor list for those models because the predictors won't be the same for predicting whether someone will buy versus whether someone will switch providers. Okay, so we have our output window like you saw before. Number of trees graphed against the ROC value. And you can see here that once we get to 43 trees, we have our optimal ROC area as 0.81913. So like I said, this is not as good as using all 15,000 predictors, but it is still illustrating the same process that you would use on the large data set. So I'm going to go to summary again and look at the variable importance. So we've cut this list down from 230 to 49, which is a huge jump and makes things a lot easier for us. Unfortunately, like I said before, we can't tell what these variables are, so we can't really draw any insight into whether or not these variables are really good predictors for our targets. And that's why we are going to do a top shaping. So I'm going to select these and do a key list. I'll submit this command file to the model setup. So now I have 49 predictors. I'm going to go into the automation and add our shaving battery. So first I'm going to shave from the top. Now before I did 20 steps from the top, but since we only have 49 predictors now, I'm just going to do the top 10. And while this is running, I'll explain to you why we shave from the top of the list. So when we shave from the top of the list, we're taking off the most important predictor first, seeing if the model increases in performance, then taking off the next, and et cetera. So why would we be taking off our most important predictor? It seems a little counterintuitive. But sometimes, especially when we can't see what the variables are, we never know if there may be a duplicate of our target variable or a direct transformation of our target variable. Or another example is if you're trying to predict sales on a certain day in the past year and you have the sales for the day after that as a predictor, of course it's going to end up being a good predictor, but you would never know if you don't know what the variables are. So we're basically trying to find predictors that are too good to be true. And these would show up at the top of your list because the tree building process is using what it thinks is best. So by taking these off of the top of the list, we're allowing room for other predictors that are actually good for your model to show up and play more of a part. And a lot of times, you won't see a difference in shaving from the top because your predictors may all be very good. In some cases, you'll see maybe the top variable come off, maybe the top 2 variables come off. So shaving from the top for 10 steps like I'm doing here is sometimes not necessary because you won't find that all 10 of your top predictors are too good to be true. It just doesn't happen very often. The other option that we have is bottom shaving. And this shaves from the bottom of the predictor list. And like I said before, a lot of the predictors that sit at the bottom may just be playing a small role in your model, or they may be sitting there as substitutes if another variable is missing. So shaving these off the bottom may either not affect your model at all, or it may actually boost your performance by getting rid of unnecessary predictors. So shaving from the bottom usually yields a smaller predictor list than shaving from the top. And finally, we have the error shave as another option. And what this does is ignores the predictor list that we looked at in the variable importance tab completely. And instead, you're looking at how the model improves by removing each variable one at a time. So if you have 50 predictors, you would remove variable 1 and run the model with the rest. Stick variable 1 back in there, take out variable 2, run a model with the rest, and you would repeat this process all the way down to a model with a single predictor. And this sounds like a long process, and it really is. It takes a lot of runs, and we don't recommend using that unless you have really been able to make your predictor list a lot smaller and start with maybe less than 50 predictors. Maybe run it overnight because it will take a long time, but it also does yield really good results. And the error shave is what our modelers use to take this final model all the way to the top of the results stack. So here we're on model 10 of 11. And as you can see, this is only taking about 4 minutes to complete, which is pretty fast. The error shave will take much longer than this. This is our results window. When we sort by ROC, like I mentioned before, shaving from the top sometimes doesn't yield any better model performance, and in this case it did not. So keeping all 49 predictors, we're still getting the 0.81893 ROC score. So this time we don't need to open this model and look at the variable importance list because we know that none of the predictors were shaved off. Instead, we're going to try shaving from the bottom. So I'll go back into our model setup. And I'm going to add the shaving battery again. This time we'll be shaving from the bottom. And I'm only going to do 5 steps to speed up this process a little bit more. And again, we only have 49 predictors, so from the original 230, we've already really made the list a lot smaller, and so we can't expect that many more are going to come off of the bottom. So I'll hit start. This time we're building 6 models, and it's always one more model than the number of steps because you're still building the full model again. So after we get this final model, after shaving off the bottom, I'm going to show you how to use this model to score on the test data set, which is then what you would submit to the judges. Because you can't just submit this model or submit a screenshot of this model and say, hey, look, I got a great ROC value, I'm all done. Because they want to test it against unseen data to see if your model would perform well in that situation, which, like I mentioned before, is just like real-world data analysis. And the test data set that we're going to use is the same size as the training data set. So it's another 50,000 customers. The large test data set has the same 15,000 predictors. And the small one has the 230 predictors that we're using in this data set here. Now what TreeNet does is it produces predicted probabilities for each of your classes and your target. So what it does is it would say there's a 60% chance that this customer would buy a product or a service and a 40% chance that they wouldn't. And so what that does is assigns a value of 1 to that customer and says, okay, this customer is likely to buy a product. And then you're submitting that information to the judges, and then they compare against what that customer actually did. So we're finishing up our last model here. And with only shaving off the bottom for 5 steps, we see that it only takes about 2 minutes, 2.5 minutes of time to complete. Okay, so here, highlighted in green, you can see our model with the highest ROC value was 0.82316. And this was an increase from our 0.81893. Again, not a huge increase. If you're just modeling and you're rounding, they're both 82, 0.82 rounded ROC. But that amount of decimal places could make the difference between 5th place and 1st place. So this is our final model after we run those 3 easy steps. We can see we have 43 predictors. Variable 126 is our most important. You can also see a number of different things like average log likelihood, misclassification, list. We're looking at ROC, and 104 trees is optimal. Now, if you're getting optimal trees at around 200, you may want to build more trees because the process might not be done yet. Like I said, we're going to say this is our final model. Once you found a model that you're happy with and you want to use to submit your results, you'll first want to go back into model setup and change your test partition, because now that you don't need to know about your 20% test model performance, you want to use all of your data to build a model so you can build the best model possible. Then what you're going to do is you're going to score this model. There's a little button down here in your output window that gives you this option. So first up here, it says Open Data File. And right now it has our training data file in here. And you can score directly back on your training data file to get predictions. And it will give you the model performance that you saw before. But we want to test this model on the data set that we were given. So here I'm going to open up the test data set. I'm going to keep the grow file as our current model that we want to score, and I'm going to save these score results. I'm going to save it as app_score.csv, which I already have here. And I'm going to save all model-related values so you can see how the process works. Once I hit score here, we get a progress bar scoring our data. What this is doing is it's taking each record from the test data set and running it through this model and producing predicted probabilities and a predicted response value. And because we don't have target variables in our test data set, we're not going to be getting any performance statistics because we don't know what those are. The judges will know what those are because they have the true target values. I'm going to open up this Excel file I just created so you can see how the scores come out. So this file contains all of the original variables here to the right. They'll give you 2 predicted probabilities and a prediction. So prob_1 in column C is going to be the predicted probability of a -1 appetency response value. Prob_2 is the predicted probability of an appetency score of 1. And like I said before, the unbalanced class distributions mean that there are a lot less ones than there are negative ones. And as you can see, these probabilities are pretty small. So for example, customer 1 had a predicted probability of 0.989985. So they were classified as a -1 in this prediction column. And this is what the judges are using against what the true values are of if that customer bought a product or a service. And so this is what you would submit to the competition to get your feedback and see how well you placed on the results board. So like I said, this is a few simple steps that you can take to try out these competitions. I want to show you that it's not as scary as it looks, it's not as hard, and you don't have to be an expert in data mining to work away at these automation techniques to just try and extract every possible relationship in your model. And we are hoping to do more of these webinars with more competitions on Kaggle and KDD Cup that use different data sets and also provide you the materials of tutorials and webinar recordings. Like I said before, you'll be receiving a recording on this webinar, the data sets, the 4 data sets that I showed you, both small and large training and test data sets, a trial download of our software, and a step-by-step tutorial. I do want to mention that your trial download will not be able to import the large data set given the memory requirements, but you can test on the small data set, and you can request a larger license capacity if you would like to try. We also have that other webinar coming up. And I did just receive confirmation that on our results board here, IZ Analytics and Financial Engineering Group of Japan both used our TreeNet software in this competition. So we can be confident that our models would perform as well as I just showed you. Again, contact us to provide up-to-date email addresses to receive these recordings and information on upcoming webinars in this series and on 3 ways to improve your regression. That's all I have to show you guys today. I will be answering a few questions, so if you haven't submitted those, please go ahead and submit them. I'll answer a few now, and we will attempt to publish the remaining questions and answers if necessary. Okay, so the first question is it retesting on the same 20% holdout set each time? Seems your shaving could just be overfitting to the particulars of that holdout set. Yes, that is correct. It is retesting on the same 20% each time based on the random number feed. And we do have an automation battery, which I can show you. It's called Partition. And what you can do is you can set this up to repeat that 20% holdout sample as many times as you want, and you can see how stable your model is performing. So as I said before, I did test that on here, and the ROC values that I was getting was about the average of about 20 runs of this partition battery, so we can be confident that it's not just a freak accident that we got that value for ROC. Additionally, if you want to make sure that that's not happening, you can run cross-validation. That way you're using your entire training data set as train and as test. Okay, so another question. Is the solver predictive modeler multi-threaded to recognize and use multiple CPU cores? There is an option in TreeNet. I think it's in the regular options. I'll have to double check on that. But yes, you can set it up to do that and use multiple cores if that is what you have access to. Okay, next question. How do you include the unbalanced distributions? In the TreeNet setup, you do have a tab here called class weight. So what happens is when you click here, you have a couple options for class weighting your target variable. So you can choose balanced class weights, where it automatically upweights small classes to equal sizes. You can click unit class weights, which makes them all equal, or you can specify your own class weights. And this may be something that you have to play around with to see what is giving you the best possible results for your particular target variable, depending on how unevenly distributed the classes are. Otherwise, sometimes TreeNet can just handle that for you, and you'll be surprised at how well it predicts classes that are really small in comparison to others. Okay, another question is how would other Salford models like random forest perform on this problem? Random forest is actually well suited to wide data, which since we have 15,000 predictors, it would perform well on this problem. We use TreeNet because TreeNet is our most accurate algorithm in this case. I can't attest exactly to how the others were performed because I don't have those results in front of me to compare. But it's easy enough to check especially on the smaller data set. You could do a few runs, and you can see how our different engines contribute to problems in different ways. And the last question is, what would you include if your entry requires you to divulge the final algorithm? So based on what we can see on the results part of the KDD website, they invite you to tell them what your approach is, but you're not required to. To divulge the final algorithm, we do have a translate button on your model. If you ever wanted to translate this model into a different language, we have SAS, Classic, C, PMML, Java, depending on if you want to look more into how the algorithm is working. You can translate it into SAS. You can look at it through that way if you wanted to submit that code to show them exactly how your tree is being built. But otherwise, they do not require that you divulge your method. Also, pertaining to the number of scores question, in our options tab here, we have general options, run at most, 4 tasks in parallel. We have concurrency and parallelism there. And this is how you would control the multi-threading. Another question we have is there a translation to R? Currently, there is not a translation to R included in our software. But we do have SAS, Classic, C, PMML, and Java. That's all the questions I've received. If you have any more, feel free to email them to support@salford-systems.com, and we can definitely get those answered for you. And if you have any other problems in replicating what I've done in today's webinar, we're more than happy to help you get through that so you can see how easy entering this competition would be. Thank you for joining us, and I hope to see you at our regression webinar in February and in the follow-up webinars we'll have for this competition series. Thanks, everyone.